Okay, here in this video I am going to solve a triangle that involves the ambiguous case. So I've done a little bit of work beforehand. What you'll notice is that I have drawn out the triangle, right, based on my given information. And it's important to identify what kind of a triangle it is. And notice that I have two consecutive sides and then an angle, or an angle and two consecutive sides. So this is SSA or ASS, right? And you need to be aware of the asked triangle because you can have 0, 1, or 2 solutions, okay? So this leads us to believe that this is the ambiguous case. Now we don't know how many solutions there are until we actually do some work, but we can tell that it's the ambiguous case by identifying the type of triangle it is. Also, if you make your box, right, with all your angles and all your sides, notice that you need to solve for an angle, right? Based on the information given, right, you would have to find angle C first. And remember that in order to find an angle, that means you have to use an inverse trig function, namely inverse sine. And when you use inverse sine, you have to find the second angle. Okay? So if there truly are two angles, what's going to happen is that you're going to find a C. In this case, it's going to be about 30 degrees, right? We'll go into the specifics in a minute. But you know that if angle C is 30 plus 20 is 50, which is definitely less than 180. That gives you one triangle, right? But, okay, if your angle C is 30, right? What is the supplementary angle? Well, that's 150, right? 150 and 30 is 180. So if your other angle is 150, using your given information here of 20, 150 and 20 is 170. It's possible to have a second triangle. Okay? That's why you're going to have two solutions. Okay, let's go ahead and solve this triangle. Let's find angle C first. So let's start out with what we know. We have the sine of B, which is 20 degrees, over B, which is 10. Well, that's equal to sine of C all over 14. Okay? So our goal is to get sine of C by itself. So we have 10 sine C is equal to 14 sine 20, which means that the sine of C is equal to 14 sine of 20 all over 10. And to solve for C, we inverse sine both sides. And so that tells us that C is equal to the inverse sine of 14 sine 20 all over 10. When we plug that into our calculators, I get 28.61. Right? But let's look at that picture, right? 28.61 is in the first quadrant here. That's 28.61. We also need to find its complement, which has the same sign. And that is 180 minus 28.61, which is 151.39. Now, okay, if this right here is 28.61, which it is, right? We know that 28.61 plus 20 is like less than 50. So it's possible to find an angle A such that we have a valid triangle, right? Because the sum of B and C is less than 180. Now let's take a look with this 151, right? Notice that we're given this angle 20. So 20 plus 151.39 is 171, which is definitely less than 180, means that we have a second triangle that's possible. Okay, so what I need to do is I need to make an entirely new table, and I need to solve this, I'm going to call this the red one, from scratch. I have my angle A, I have my angle B, which is still 20, that's given. And then angle C I just found, and that's 151.39. Okay, I don't know what A is. My B is still 10, that was given. And then C is 14, and that was given. Okay, I need to solve this red triangle separately for angle A and side A. But in the meantime, let's just go ahead and finish this first triangle. Okay, I start again with what I know, and that's the sine of 20 over 10. Now, the one thing that I forgot to do is solve for A, right? Because I know what angle B and angle C are, I just add them up and subtract them from 180, and now I know that angle A is 131.39. Okay, I need that for this next part here when I solve for little a. So I have A sine 20 is equal to 10 sine 131.39. So that tells me that A is equal to 10 sine 131.39 all over sine of 20. I don't know why my pen is selectively writing. But anyway, when I plug that into my calculator, I get 21.94 for A. And by doing a quick glance, right, angle A is my largest angle, and that's opposite my longest side of 21.94. Angle B is my smallest angle, which is 20 degrees, and that's opposite my shortest side, B, which is 10. Okay, so I have solved one triangle. That's my black triangle. Okay, now what I'm going to do is I'm going to go through and solve the rest of my red triangle. Okay, so that's all the information I have, right? The last thing I did was to find angle C. So now I need to go through the exact same steps as I did previously. I start with what I know, and that's sine of 20 over 10 is equal to, oops, what I forgot to do is find angle A, right? I know that A, B, and C add up to 180. If I know B and C, I add them up, subtract them from 180. Angle A is 8.61 degrees. Okay, that's what I'm going to do for my ratio here to solve for A using the law of sines. So I get that A sine 20 is equal to 10 sine 8.61. So A is equal to 10 sine 8.61 divided by sine of 20. I punch that into my calculator and I get 4.38. Okay, and this 4.3 is definitely my shortest side. That is opposite the smallest angle. Similarly, my side C, which is 14, is opposite my largest angle, which is 151.39. Okay, so when you have the ambiguous case and you have two possible triangles, you need to solve them separately. Okay, now the way you can check to see that you have exactly one solution is that when you use the inverse function to find this angle C, for example, it might be A, it might be B, depending on what the problem is. If your second angle, right, when you do your inverse sine, you find that second angle, the supplement, if your supplement plus the given angle is greater than 180, then you know you only have one triangle. Okay? Now there is a case where if you do your inverse sine, you're going to get an error. Like if you do it correctly and your calculator gives you a domain error, that means that you have no possible triangles, and that's where your angle is too big and your triangle won't connect. Okay. Now just to tie this back into the applet that I showed you in GeoGebra, this is what's going on. I know that our naming convention is different, but essentially you're given two sides in an angle. And you can see here that you have a smaller red triangle, right? That's what we had, and then a larger black triangle. And you can see the solutions here. And that matches up with what we had. Okay, so be careful with the ambiguous case. And remember that whenever you inverse sine or use any inverse trig functions, you need to find the second angle.